Okay, hi there. This is chapter 13, so we're getting close to the end of our class. This is more of a conceptual chapter, so that's nice. It's called Chemical Equilibrium. So let's look through this one together. So read the opening essay, understand what this definition is. Most of the time when we do chemical reactions, we see a one-way arrow. But in equilibrium, you're going to see a two-headed arrow showing that reactions can go left and right. They can go backwards and forwards. So that happens a lot in the reactions that are in our body. So understand the definition and concept of equilibrium. And then the math that comes in is called the equilibrium constant. So we're going to learn how to calculate this thing called a K value. And you'll see it as KEQ. Different K's depending on the equilibrium that we're talking about. So K is the general letter we're going to use for equilibrium. So take a look at this, understand how it's set up, and we're also going to have some conceptual things in this chapter. So moving on, we're going to have things called KQs, KPs, depending on the situation. So we'll know that generally we're going to have a K, but we might have other little sub designations depending on the situation we're talking about. So keep moving on here. Get to the important stuff. So this is the most important section of this chapter. It's called Le Chatelier, and it says if we have a reaction that's going towards products and then reversing going back to reactants, we can manipulate that situation and get what we would like to have happen. So we can manipulate the equilibrium and make it move to where we want it to move. So this topic is more conceptual, so I need you guys to know the Le Chatelier's principle and then what you could do to affect a change in a reversible reaction, a reaction that will go to the left and to the right, towards products and reactants, backwards and forwards. So this is important. This whole is more of a concept thing though, so it's not the math for Le Chatelier. It's going to talk about heat a little bit in here and what a catalyst will do to Le Chatelier's principle in a reaction. And these problems are important to try to figure out what's happening. So look through these problems here. See if you can figure out what's going to happen. 3 and 4. This is what I would have on a quiz or a test. And then calculations will be another thing in this chapter, and we're going to use molarities like we've used in the past. And so remember the brackets mean molarity. So use the brackets to signal that we're in molar. So remember big M means molarity. So we have to have molarity first. So you might have to do a problem where you do molarity, figure out the molarity first, and then use that in a equation for K. We're going to use something called the ice chart. These can be a little intimidating, so we need to work on these a lot. This is the section you need to read the most in this chapter, understanding the algebra to figure out this ice chart. So please take a lot of time to review this part. It's important, and it will help you figure out K values or unknown values for molarity. So go through this example through the book and make sure you understand how they're doing it. Ice charts are important, and at the beginning they're not easy to set up until you get really used to them. Okay, so make sure you go through these. We've talked about acids and bases, so we can use this K value in acid dissociations and in base dissociations to find a Ka or a Kb. And it has to do with just a designation for a K value for a reversible reaction. And when you find a K, you can find the actual value. You can use these backwards to find molarity. So we'll be using these constants a lot. You just have to find the right constant off of a chart. And the K values, if they're big or small, tell you a lot about what's happening, whether the reaction goes to the left or to the right. And then this is also a relationship that's similar to that KW relationship that we talked about in the last chapter. So this is important. Remember we talked about this K before, so this is an important thing to know. This is something you should memorize. And what do the brackets mean? Remember they mean molarity. And then we can also do something called a KSP, solubility product. So this is a K value that's figuring out the relationship of the something that's dissolving in a solvent. And we can get a KSP value. So these numbers can tell you if something likes to dissolve in water or in a solvent or does not like to dissolve in a solvent. We generally talk about solubility products in water. So try those KSP ones. And then here's where the homework is for chapter 13. So concepts and math in this chapter. So take some time on this chapter. And good luck, and I'll talk to you soon. Bye-bye.